Good morning, children. How are you all? Hope you all are keeping well. Children, today we will start chapter number 7 Sound. Sound and music are a part of our everyday sensory experience. Just as we have eyes for the detection of light and color, we are equipped with ears for the detection of sound. Children, when we hear some sound, do you think does any part of our body vibrates? Or when we speak, do you think any part of our body vibrates? Yes, when we hear any sound, the eardrum which is in our ear, it vibrates. Likewise, when we speak, the vocal cord also vibrates. So, in your earlier classes, you have studied about the mechanism by which sounds are produced and how they are propagated in the form of waves. Sound is produced when a object vibrates and it is propagated or it travels in air in the form of waves. Sound is a mechanical wave that is created by vibrating objects. It is propagated through a medium. It requires a medium which to travel from one location to another. In this chapter, we will learn about the properties and characteristics of sound waves and apply the basic wave principle to understand the working of some musical instruments. So children, the first topic is sound waves. As I told you that sound requires a material medium for its propagation, so it travels in the air in the form of longitudinal waves. Now what is a longitudinal wave? Longitudinal waves are those waves in which particles of the medium through which the sound is transported vibrate parallel to the direction in which sound wave moves. That means the particles of the medium vibrate parallelly or it moves parallelly in the direction in which sound wave moves, and the result of such longitudinal vibrations is the creation of compression and rarefaction within the air. As a sound wave moves forward, it creates a series of regions of high pressure called compression, and compression means where the density of air is higher than normal, and regions of low pressure called rarefaction where the density of air is lower than normal. These compression and rarefaction comprise a sound wave that propagates through the medium in the form of longitudinal wave. Now see children, each wave is different. Not all the waves are the same. Each wave is characterized by properties such as frequency, time period and the amplitude. These are the three characteristic property of any sound wave. So first of all, we will understand about the frequency. What is frequency, children? The particles of a medium through which the sound wave moves vibrate in a back and forth motion at a given frequency. That means the number of times in which the number of times a particle of the medium moves in a back and forth motion is known as its frequency. The frequency of a wave is measured as the number of complete back and forth vibrations or oscillations of a particle of the medium per unit time. This means what? The number of vibrations per second. The number of vibrations per second is called the frequency. That means in 1 second how many vibrations does a particle makes, that is known as its frequency. A vibrating object could be the vibrating strings and the soundboard of a guitar or violin, the vibrating tines of a tuning fork, or the vibrating diaphragm of a radio speaker. So what is the frequency? Frequency is the number of vibrations completed in 1 second. Now the next characteristic of a sound wave is the time period. What is time period? The time taken by a vibrating object to complete one complete vibration. The time taken by a vibrating object to complete its one vibration is called its time period. It is denoted by capital T. The SI unit of time period is seconds, whereas the SI unit of frequency is hertz. Small HERTZ, hertz, which is abbreviated as capital HZ. Okay, so but the time period and frequency are inverse of each other. The relationship between frequency and time period is what? F is equals 1 by T. That means you can easily find out the frequency or the time period if any one of them is given to you. This is the relationship between the frequency and the time period. Frequency equals to 1 by time period, where the SI unit of frequency is second, whereas the SI unit of frequency is hertz, or you can say per second. Hertz or per second. Okay. Now what is amplitude? When an object vibrates, it moves away from its mean position. The maximum displacement of a vibrating object from its mean position in a medium is called its amplitude. The SI unit of amplitude is meter. A high energy wave is characterized by a high amplitude, whereas a low energy wave is characterized by a low amplitude. For example, if you have two waves, you can see it has a high amplitude. This is the amplitude, whereas this is the low amplitude. Okay. So the maximum displacement of a vibrating object from its mean position in a medium is called its amplitude. Amplitude and frequency are two important characteristics of any sound. Frequency determines the pitch of a sound and amplitude determines the loudness. Always remember, frequency will tell you the pitch of a sound, whereas the amplitude will tell you the loudness of a sound. When the amplitude of the vibration is large, the sound produced is loud. And when the amplitude is small, the sound produced is feeble. The greater the amplitude of a wave, the more the energy it can carry. So you can easily say if amplitude is more, loudness will be more. If amplitude is less, loudness will be less. And if amplitude is more, you can say that the sound energy carried by that wave will be more. Now, characteristic of sound. Sound has basically three characteristics: pitch, quality and loudness. Pitch, quality and loudness. What is pitch, children? See, children, have you ever wondered why each one of us has a different voice? You can easily recognize anyone's sound without seeing that person. How you can identify? We can easily identify a female and a male voice without looking at them. So the frequency determines the shrillness or pitch of the sound. If the frequency of the vibration is higher, we say that the sound is shrill and has a higher pitch. If the frequency of vibration is lower, we say that the sound has a lower pitch, or we can say it has a low pitch. For example, you might have seen when a small baby speaks something, his or her voice has a high frequency. So a baby has a higher pitch than the pitch of a man. Likewise, the pitch of a woman is more than the pitch of a man. So pitch depends on the frequency of vibration of the waves. If the frequency of vibration is high, we say that the sound is shrill and has a high pitch. On the other hand, if the sound is said to have a low pitch, then it has a low frequency of vibration. Now, if I'll ask you which sound has a high pitch, a chirping of a bird or the roar of a lion, then you can easily say that the chirping of a bird is a high pitched sound, whereas the roar of a lion is a low pitched sound. Now, next characteristic of the sound wave is quality. So, see, children, since pitch depends on the frequency, you can easily see in this is a wave which has a lower pitch, whereas you can see the number of vibrations completed in 1 second is more in this wave, so it is a higher pitch. Okay, if the frequency is more, the pitch is more. If the frequency is less, the pitch is also less. Now the next topic is quality. What is quality, children? If two musical instruments, say a guitar and a violin, are producing sounds of the same pitch and loudness, but we can distinguish between them, no? If two people are playing guitar and a violin together of the same pitch and of the same loudness as well, but still you can tell which sound is of guitar and which sound is of violin. Then how are you going to differentiate between the sounds? If the sound produced is of the same pitch and of the same loudness, still you are able to recognize the sound or differentiate between the sounds. Here comes the characteristic called quality. Sound quality comes into action. What is quality? Quality distinguishes between various sounds and is dependent on the source that produces the sound. That is why each musical instrument produces a different type of sound, and each friend's voice is different from the other. You can easily recognize if the person who is speaking over the phone without that person telling his name. You can easily identify that this person is speaking over the phone. How you can say this? Because of this quality. Now next is loudness. What is loudness, children? Loudness is a characteristic of sound. It distinguishes a weak sound from a loud sound. The loudness of a sound depends on the amplitude of the sound wave. The more the amplitude, the louder is the sound. As I've already told you, pitch depends on the frequency, whereas loudness depends on the amplitude. If amplitude is large, the loudness will also be more. The loudness of sound is proportional to the square of the amplitude of the sound vibration. That means loudness is directly proportional to the square of the amplitude of the sound. That is why if you increase the volume of a TV, the sound becomes louder. Why? Because you are increasing the amplitude. This is actually done by increasing the amplitude of the sound wave. A sound wave with larger amplitude can cover longer distance. We can hear a louder sound from a far distance. The loudness of sound is measured in units. What is the unit of loudness? Loudness of sound is measured in units called decibels. This is the unit, and in symbolic form we can write decibel is like this. Okay, decibels. Okay, now children, next topic is pitch and frequency in relation to working of musical instruments. Now see children, we have usually three types of musical instruments which are based on the factors of pitch and frequency. Musical instruments can be classified as stringed, wind or percussion instrument based on the characteristic of producing sound. First type of musical instruments which we are going to discuss is stringed instruments. What are stringed instruments? Stringed instruments produces sound due to vibration of the metallic string stretched between two fixed points on the instrument. In a guitar, the vibration can be produced by plucking the strings, and in a violin by drawing a bow across the strings. The instruments which have strings to produce sound, because the strings are going to vibrate, they are known as stringed instruments. Okay, for example, you can say veena, tanpura, sitar, piano, cello, etc. These all are stringed instruments. Now the frequency and pitch produced by any of the stringed instrument depends on three factors. First of all, the length. The short strings have high notes. That means if there's a short string, it will give a sound of high frequency. Likewise, mass per unit length. That means thickness of the string. Thin strings give higher notes. That means what? If you pluck a thin string, then it will produce a sound of high frequency, or we can say high pitch sound. After that, tension of the string. How tightly you tuck the wire. Tight wires produces high notes. If any wire is tightly tucked in the guitar board, then it will produce a sound of high note. Okay, now the next topic is wind instrument. What are wind instruments? In some instruments like the flute, mouth organ, pipe organ or clarinet, what we do? We blow the air and the air column vibrates. So these instruments are known as wind instruments. They produce sound by the vibration of the air column when air is blown through them. The frequency of sound can be changed by altering the length of the air column. You might have seen in a flute the holes are made. Why those holes are made? So that you can close any of the hole and you can adjust the frequency or the pitch of the sound produced by those flutes. So you can easily alter the frequency of sound produced by any wind instrument by opening or closing the holes in these instruments. Now last is percussion instruments. What are percussion instruments? In instruments such as the tabla, dholak, mridangam, dhol, there is a stretched membrane. You have seen, I hope that you all have seen any dhol or a tabla or a drum. What how they look like? They have a stretched membrane which produce sound. When you tap those stretched membrane, what happens? A sound is produced. In these instruments, the tone is produced by tapping sharply, striking, shaking, or scraping the membrane which covers the hollow cylinder or the hemisphere of the instrument. The nature of the sound produced by a percussion instrument depends on the size and nature of the membrane as well as the tension with which it is stretched. You might have seen before playing the percussion instrument, the person who is playing that, they tightly stretch that membrane so that a good sound will come. So the pitch of the sound depends on the how tightly the membrane is stretched. Okay, you must have observed tabla players adjusting the rope or screw with which these are fixed. And some other examples of percussion instruments are gong, cymbals, congo, drums, xylophone, and vibraphone. Now, children, these are the topics which we have covered today in this chapter, chapter number 7, sound. I hope that you will read this chapter and understand it well. Kindly do all the exercises given at the end of the chapter and read the chapter well. Thank you, children.